Hello. So, am I audible? So, let's start the live stream. Nice. So, this is okay. So, really hate this. Damn, this is better. Okay. Why is it lagging so much? No. Okay, why is this lagging so much? Okay, okay, better than before. Can I reduce? Okay, there's a lot of latency right now. I'll let the internet stabilize. I know you're not able to view me. Mm, One more thing I need to do is, and the fuck, I didn't ask for FaceTime. Mm, I asked for Finder. Hello. Yes. So here this is. Okay. If I'm not wrong, so into this users. Let's see. There must be something in the movies. Yes. Today is 17th. I'm going to delete this because already live streams are getting saved on YouTube. Nice. So I have removed the data and I have increased my disk space. How the fuck? It's still 300. Okay. So frames missing. Okay. So I hope the stream has stabilized enough for me to start. Is there something useless I can? Okay. So I can remove this also, right? Okay, so this is just a second. Dogs. Then I can remove scenes also. Nice. Way better. Way better. So now I can just do this and we are live. Now you're able to take a look at me. So first of all, what we are going to start with is I'll try to explain what we did in the previous stream with help of some drawings. Hopefully my system does not crash. Hopefully, which I feel it will because I'm running a way older Mac which doesn't have capacity to do all this kind of stuff. Yes, I should have So I was going through a lot of stuff. Yes, so I can just delete this. I can add a section here. It is rough notes, and then let's make this React. Nice. So where have I mapped it? Okay, cool. So previous. Okay, so first I'll open the code and we'll walk you through it. So we were technically writing colon DOM. So this is DOM rendering. So the entry point for our code is render, right? So this is the entry point where we define some element and containers. So initially, globally, there is some context in JavaScript globally, which is we have a okay. So first of all, okay. So since this is global, I'll write those in green. So we have a work in progress root. So it is the current root, current current virtual DOM. So VDOM, current VDOM getting worked upon. So just a second. So as we can see, so this is okay. So I'll just reduce the thickness. So current VDOM getting worked upon. So we have a virtual DOM, which is first we have two virtual DOMs. So I'll just erase this. We have two virtual DOMs, not virtual DOMs. We have one DOM, and then we have a current virtual DOM which we are working, which we are currently rendering in memory. So not, we cannot say in memory, but yeah, in code. So we have another virtual DOM. Assume it to be like this, and the entry point, not the entry point, but the parent container, which should contain this virtual DOM. Let us assume this to be this. So rest every virtual DOM, which you can mark like this, is pre-rendered using HTML. So these are statically rendered. We can say these are static rendered. Okay, so now we have this virtual DOM which we have worked upon. We have worked upon. This is in memory slash not rendered. Now we have rendered this, and as you can see, this is the entry point. So we will replace this complete part with the new virtual DOM. And how do we do that? We do that using a recursive call to create root. So we'll go through the code and I'll explain you how technically this is working. So first we'll write out the global context. So just a second. Yeah, we'll write out what are the global variables, because those are very useful here. So I'll just remove this, remove this, remove this. Okay. So I don't know why this isn't getting it. Maybe I know why. Okay. So the system is fucked up right now. I'll tell you why. Am I even streaming? Yes, I'm streaming. Okay. So sorry for this, but if we are into code currently. So if we can see, if you go to line number 001, these are the global contexts, like global variables we have. So we have current root, work in progress root. So just go here. We have a current root, we have a work in progress root. So current root is the rendered one, and then we have deletions and next unit of work. So we also have deletions which contain deleted nodes, and we have next next piece of work, next unit of work, next unit of work. So if we go through the code, what we do is we call render, we actually pass values to these null context. So how this works is we provide an element and a container. Okay, so container, so let us assume there is already a statically rendered DOM. So this is of course HTML. Then you have head and maybe there will be some script tags in here or style tags. And so we can have a title tag here, title. We can also have a style tag. Okay, cool. And then we have a body tag. Assume we have rendered something statically here. Let it be some sort of h1. This is statically rendered. And then we have a div with id equal to app. Okay, so now this is the container. Okay, and then we have the dynamically generated virtual DOM using React. So let me draw it something like that. So we have something here, something here, something here, and here something here, 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 and here. Okay, so let this be again h2 tag. Let this be some code tag. Okay, not code tag. Wait a second. Of course, I cannot erase this because it hasn't synced yet. So because it hasn't synced, I cannot erase this. But yeah, assume it to be a code tag, and then we use some bold tag or some italics tag inside code tag. I don't know if we can use it or not, but yeah, let's assume this. And then we have h2. We can have some sort of p tag here, paragraph. Then we have a p tag. Then we can have, what can we have? What can we have? Let us assume we have an a tag. So this is a link, and inside that link we again have a code tag. Okay, so assume this is the structure. I haven't used any input parameters because we haven't implemented what do you say, on effect or anything. I have not tried to make it complicated using buttons or input and system like that. Yeah, I guess our notebook is saying now. Whoa, 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 whoa. So this is how we are going to render everything. Exactly the way it is. Nice, nice. Okay. But why everything is blue? So I can technically do this. Okay, now it's actually not working. Okay, so let us ignore that. So you understood, okay. So from here on, it is the virtual DOM, the dynamically generated by React. Okay, so now we can see render needs an element which is this here. This is made up by hello world. Hello world function actually returns this tree, and then we need a container. Container is this part right over here. This is container. Okay, so this creates this. Now we have request idle callback. So this is the part where everything gets rendered. So you can see right in this file, we are not calling any function. These are just definition. Not even a render is calling any function. So then how can, without calling any function, we are rendering anything? So that is because of this right over here. Of course we are calling this, and we are calling this with a callback function. So what is request idle callback? Technically we can go into the documentation. So let's go into the documentation. We can do that. So yeah, and if I'm not wrong, line number 18. So as you can see, method queues a function, so it queues the callback function, not callback technically, but queues a function to be called during a browser's idle period. So when browser is sitting idle, so now we have rendered everything, right? Now the browser is sitting idle unless and until we give it some input, or we do like we like trigger some events or not, or and all that. But unless until we don't do that, it is sitting idle. So when this is sitting idle, it calls a function again. Yeah, it is callback. Yeah, so it calls a function. Okay, so on the main event loop, this enables just okay without impacting latency critical events such as animation and input resource. Correct. Okay, so technically this has a queue. The browser has a queue. Whenever it is idle, it will push this callback function into the queue, and when it is idle, it will of course dequeue it and run the function. Okay, so that function is always ran when the browser is sitting idle. So if we go back to our code, and we can see we are calling work loop. So if we see this function right over here, so we have this should yield. Should yield is like, okay, assume it to be the syntax of Go generators. So you yield the output, but it doesn't kill the main function. It doesn't kill the main function. It doesn't restarts its whole stack, its local variables, its scope. So so there's a boolean flag like should the function yield, and then we check if we have next unit of work which we have defined in render. That means that this exists, and there is some work in progress route which also we have defined. That means both the conditions are clear, and we can okay, so we can then, just a second, we can then call commit root. So what does commit root do? So we can check here. So it takes on deletions. Deletions is an array of deleted. Okay. I guess we missed something. Okay, we missed it. So we have a boolean should yield, which is false. So the function won't return anything. Okay, then we check if we have a next unit of work. Yes, we do have a next unit of work because we called render. Render has next unit of work defined inside it, which is not null or undefined in context of JavaScript, and should yield should be false. Yes, we are not yielding anything, we are not returning anything. Then we can enter the loop. Okay, now what does the loop do? It performs a unit of work. What is a unit of work? You can go to definition. Yeah, and we can see. Okay, sorry, but you can see perform unit of work. So we have perform unit of work. So it takes a fiber, so we can see right over here in the work loop that we do pass the next unit of work. So perform unit of work takes in the next unit of work and performs the work. So what is that work we are performing? So it takes in a fiber. So fiber is what we can say is a basic unit of work in React. And how does the structures of fibers look? How does the structure of fibers look? It looks like a tree, and we call it virtual DOM. So first it takes in a fiber, and then it checks, have we created a DOM element for that fiber? If not, create the DOM element. So if I can just do this, sorry for that, but yeah, if I can just do this and go to definition. So create DOM. So you can see if it has text, it will create a text DOM element. Otherwise, it will create an element, right? You can look at this here. It creates an element. It passes on the properties. It passes on the properties. So this also they like will come back to update DOM, but this passes on the properties. Okay. Yeah. Now this makes sense. This is fine and yes. Okay. So again, uh, so we do have this, and if we yeah, so we create the DOM if the DOM does not exist, and then we look at the children. So we look at the children. So now we can start doing this. So what we can do is we have this node right over here. We created its DOM. This was the next unit of work. This DOM, this fiber. Let's not call this DOM node. Let's call this fiber node H1 was next piece of work, and it was taken upon by perform unit of work. So a unit of work was done on this. A DOM element. So this is DOM, this is virtual DOM, this is fiber, and this is DOM. A DOM element was created and attached to this. Okay, and then we actually iterate over its children. So what we do is we have elements is equal to fiber.props of children. So it will look at the children. So if we just go to reconcile children with definition, and then yeah, we go to its children. So assume it goes to like p is stored first. Okay, so it goes to p. Now okay, so now let's look at the code. We have index 0. Let previous sibling is equal to null. Okay, let's get that out of context. And let old fiber is equal to work in progress fiber dot alternate. So currently we are creating the DOM for the first time. Assume this was already created once and we were applying some changes. Then this would have been an update or deleted or any other stuff. So we also keep an older version of the DOM to just see what has changed. So that is a different thing, yeah, of course, but we are creating it right now. So old fiber would already be null because we are creating it for the first time. Okay, and then we do index less than an element dot null, and we loop over all the children. So if you can see, we loop over all the children, we create the fiber, and the old fiber doesn't exist. We create the fiber, new fiber for the child, and we keep on creating it if index is 0. Okay, now this is the interesting part. So now if the index is 0, now initially this was the unit of work. We created the DOM attached with it, and then we moved on to the children. Now if the children is the first one, if its index is equal to 0, then this is the right heir, the eldest son, the eldest daughter, the eldest child is the rightful heir of this king. So we can say this node is then child. Also, this is also going to be the next unit of work in the second pass when the browser is sitting idle for the second time. So we can see, look over here, line. So line number 20 is like relative line number 168. If index is equal to 0, we we say the eldest child is the is gets a very significant place. And if there are other child, so now the other child is code. No, it isn't a, it is code. It isn't a, it is code. We are looking at children of h2, not p. So the second child is code. So I can actually make it like this. So this is code. But why did I make it in dashed line? It is because everyone is recognized by their eldest sibling, or if they are the eldest sibling, they are recognized by their parent. So this code is actually recognized by this eldest sibling, because this child is younger than this child, so this gets low preference. That's how Asian societies work mostly. So yeah, so we assign it to the sibling. Okay, and then we say previous sibling is equal to new fiber. So now we consider this as the previous sibling. So if we had any other node, any other child, it would have been here, and this would have been linked like this. but we don't have any other child, and I don't think so eraser is going to work. Yeah, it's not going to work because it's not syncing apparently. Okay, nice. So now what we can do is, now if we have understood this, now we return. So we don't return anything, we just pass the children like this. And then after reconciliation, so if I do, yeah, so after reconciliation, if the fiber has a child, now listen to it very carefully. If the fiber has a child, return fiber dot child. So this line, if fiber dot child exists, return that. That means mark this child, the eldest child, as the next unit of work. Now, when the browser is sitting idle, now we take P as the next unit of work. We create its DOM and attach that with this. Now, since this is attached, we again repeat the same process. We look at its children. We now P has A, so we have A here. Now, does it have any sibling? No. So we don't have any attachments here like this. We don't have it. Now again, this will be returned since this is the eldest child. Okay, so now if this is returned, listen carefully. This is the next piece of work now. Again, similarly, the same thing will happen to code, but now code doesn't have any children. Code doesn't have any children. So what happens is, if fiber.child exists, but for the lowest of the lowest level, there is no child. He is childless. So what we do, we just go a step down. We say let the next fiber equals to current fiber. Okay, so now we go here, we go code on code, and let us say this is the next fiber, and see if there are if there are siblings. Okay, what if there are no siblings? That is a good question. What if there are no siblings? If there are no siblings, okay, 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 okay. So if there are no siblings, the function returns void. The stack is popped and we move on to A. Now does A have any sibling? No, we move on to P. Does P have any siblings? Yes. P do have a sibling which is code, and code is recognized as a sibling of P. Of course it is recognized as child of HQ, but this is a more significant path link. So now what we do is, we take P as the next fiber. Now we check if the next fiber has sibling. Return the next fiber as this. So now the next piece, like the next unit of code, is this code tag. Again, we have this code fiber, we create a DOM, we attach it to this. Okay, so now we have attached this. What we can do is, now this is attached. Again the same thing happens. We have the eldest child, that is I tag. Okay, and then we have the sibling child, the younger sibling, which is B, and B is recognized as smaller brother of I. Now the next unit of work will be I. We will create its DOM, attach it, and then we'll look, it's childless. Since it is childless, we will move on to B, and B will be attached to its DOM, and of course since it is childless, we'll move up to code. Now we have moved up to code, right? So code now doesn't have any child, nor does it have further siblings, younger siblings. So the whole perform unit of work ends at the original h2 container. So since h2 is the root here, like the starting of the virtual DOM, it ends there. So since it ends there, we can see the next unit of work, perform unit of work, unit of work, unit of work, unit of work, and the next time it will perform it, it will be thus return would be null, right? Again, we also check if the deadline is has not passed. So deadline is like, um, we assign a certain time. The browser is not going to give all of the time setting idle to this function. It does have a time. So if that time remaining is passed, then we set should yield. Okay, we should set. Okay, so if the deadline time remaining is less than one, that means it hasn't crossed the time remaining. So like, we still have some time, so we can mark should yield us true. Correct. Now if we don't have next unit of work, when are we not going to have next unit of work? When we have exhausted all the children and all the siblings, then we don't have any next unit of work. So if next unit of work is null, it's not inverse would be true. And we have a work in progress route? Yes, we have a work in progress route. We haven't changed it yet. So then we start committing it. What do you mean by committing? So we have attached all the DOM, we have created the virtual DOM. Now we want to replace this with the newly created version of DOM. How do we do that? We do it using commit work. This is also a recursive call. This also does a recursive call. So first of all, we see if any nodes are deleted. Of course, here no nodes were deleted because we were doing the first pass. So we leave it. If it is deleted, we delete it. Otherwise, we leave it. And then we go to commit work. And commit work checks what was the kind of changes made to the virtual DOM. Were new nodes added, which is called placement? Were the previous nodes updated, which is called update, of course? Or were the, what do you say, nodes deleted? Then it's known as deletion. And then we commit the work. So we commit the work of child and then we commit for sibling. And of course, eldest child are given more preference than the siblings. This is how you should learn. Or in like more formal way, it is DFS. We are doing a DFS over the virtual DOM. And then of course we commit the work. It calls update DOM. Now what does the update DOM do? It just takes the, what do you say? It just takes the props, the attributes, and it just updates it, deletes it, or creates it depending on the changes made to the virtual DOM. And once the update DOM is done, the React work is the commit work is done. It is returned. Commit root is also returned. We mark current root as web root, and web root is equal to null. So we have a previous context, and we have marked the new context as null unless until there are certain changes made. And when the set changes would be made, it will be called using render. So underscore render, right? So this is how thing work. This is how this thing works. If you want to have a very like better understanding, I can just tell you how it is getting rendered. So first we will render the static content HTML. Okay, then we have head, then we have body, and now let us assume this has a dev name app, and now here we attach the virtual DOM. So how does it create the virtual DOM? It will create the first node. It will then go to the eldest child, create that node. It will then go to its eldest child. Of course, now this is childless, so it will pop up here. See for its siblings. Okay, now this is childless. Now it will see for this if this has any siblings, but this doesn't have any sibling. So then it will jump here. Of course, this does have a sibling. So now this will get rendered. Now its child will get rendered. Eldest child. Now its child will get rendered. Does it have any siblings? No, it doesn't have. So it will jump to the parent. Does it have any sibling? Yes, it does have a sibling. So we will generate this. Okay, cool. Does it have any children? No. Does it have any sibling? No. So then we'll move on to the parent. So we move on to the parent. Now we check if it has any another sibling. So yes, it does have a sibling. We create it. Now does it have any children? No. Does it have any sibling? No. So it is both the youngest and childless. So least priority. So we can see 1, 2, 3, 4, 5, 6, 7, and 8. This is the rendering pattern, and this is the graph. The dotted lines represent siblings. So this is how it is getting rendered. So 1 2 3, then it jumps here 4 5 6, then it jumps here 7 and 8. So technically this is DFS. We first go inside it, we see nothing else, we again come out, we go inside this path, we see nothing, we come out, till here, we see a path here, we go here, then we come out completely, and again we go here, and then we come out here. So this is a DFS. That's how we render it. The another method of rendering would be BFS. So we first render the parent, then we prioritize rendering sibling over child, and we can do like that also. There is nothing wrong with that. We can do it in that way. But again, I was following a tutorial and it went with DFS, so we also went with DFS. So this was the gist of how actually our code works, especially the render part. So today, okay, let me first check how much time has been used. So okay, so today we are going to follow the tutorial ahead. Um, so we will follow it ahead. So now so initially we, of course, we did everything. We did all this. We also added support for event listeners. So it now updates the events also. Now we will go to function components. The next thing we need to add is support for function components. First, let's change the example. We'll use this simple function component that returns an H1 element. Okay, makes sense. Okay, now that if we transform the JSX to JS, it will be okay. Just a second. Redact dot create element. Okay, makes sense. Makes sense. Yeah. Function components are different in two ways. The fiber from a function component doesn't have a DOM node. It doesn't have a DOM node. Makes sense. It doesn't have a DOM node. And the children come from running the function instead of getting them directly from the props. Okay, yes, makes sense. Okay, cool. So we run the function. So here also, if you see, just a second. Okay, yeah. So I can now put this. So if we see, take a look here, what I did in JS6. You can see I was calling this, but this is not how things work in React. So what happens in React is we call it like this. But here we are not doing that. So now function component. So of course, yes, we first check if the fiber type is a function. Okay, makes sense. And depending on that, we go to a different update function. Update host component. In update host component, we do the same as before. Okay, so what we need to do now is, of course, we need to do this. So just calm down. So we can see we were directly creating a DOM and attaching to it. But what if the fiber is a function? You cannot attach a DOM for a function. It doesn't exist, right? The DOM equivalent thing does not exist. Then what can we do? So we check if it is a function or not. So we do this. Const is function component. So that is equal to fiber dot type instance of function. Instance of, wait a second. Okay. Instance of function. But then why isn't getting highlighted? It's a new function. Instance of, okay. Maybe it doesn't support syntax highlighting for these keywords. So if is function component, of course update function component fiber, else update host component fiber. And then we do reconciliation here, correct? So okay, so first we used to handle only the real components. So we take that code, we take this code, we create another function update host component which takes in a fiber. I'll paste this here. Nice. So, ooh, when I was explaining, I was covering a part of screen. But the second explanation would have helped where I have drawn the whole tree diagram. Yeah. So, update host component takes a fiber. If DOM does not exist, it creates a DOM. But I don't understand one thing. The elements were here, right? Where did the elements go? Okay, so they were directly getting called here, which makes sense. It was a useless line, anyways. I don't know why we were defining it, but yeah, we'll just delete this blue and we'll paste it here. Okay, makes sense. And now I so we created fibers, we went to reconciliation and the incoming phase, and now we have okay, we have different tags, and now we are working on function components. So yes, so if is function component. So if is function component, if it is a function component, then we update function component, otherwise we update the host component. We update function component or else we okay, so this is not good, else okay, so this is good, but how else have I written else? So then must be like this itself here. So for consistency I need to do this, else update okay, update host component. Cool. It takes in a fiber now. We have to do update function and we call the function. Okay, so damn, it directly jump. So it doesn't attach a DOM. Fuck the DOM. We will directly go to the children because it's a fake parent. So technically, the children are adopted and the parent is infertile. So parent is infertile. It's a function component. If parent is infertile, then that means children are adopted. Just directly jump to the children. Don't need to render the what do you say, infertile parents. So we are against infertile parents. Yes. So no case of abortion. So what we do is perform it first, and then yes, update function components. So okay, update function component fiber. Ah, I'm very bad at typing. Okay, and then what do we have here is we directly reconcile children. Okay, so type. So technically we are calling the function. We are calling the function here, and this returns the children. So calling the function returns the children. Makes sense. Makes sense. So what we can do here is fiber dot type, execute this function with fiber dot props. So yes, this shall work. Nice. So this will work. Now we need to change is the commit work function. Now that we have fibers without down nodes, we need to change two things. First, okay. So first, to find the parent of a down node, we need to go up the fiber tree until we find a fiber with a down node. Okay. So now we recursively go up. We recursively go up here because someone in the middle was infertile. That's why we remove them from the family tree. We just overpass them. So if you have grandfather and if you have your father and your father is infertile and you are adopted, we directly jump to your grandfather. We don't jump to your father because he was useless anyway. Same goes for the other side. I'm not that careful. So yeah. Let dom equal to fiber dot parent while fiber dot parent dom does not exist. We keep on moving up. We keep on moving up. We keep on moving up. Makes sense. I'll just copy this code and then commit work easy. Just paste this one. Yeah, we just use this. And yes, we recursively go up. Okay, and what is this again? And then removing a node, we also need to keep going until we find a child with a down node. Yeah, makes sense. So there we need a commit deletion. Damn, that's not bad. So deleting is also a difficulty if you are infertile. So if we go to, we cannot do this now. Of course, we cannot do this because if it might be a function, what is a function component. Yeah, it must be a function component. That's why we cannot remove the child, right? So we cannot remove that. We cannot. What do you say? We cannot remove a function component, a component which doesn't exist, which does not exist, which we have created for convenience. So we need a real physical DOM object. Anyways, everything is digital. So, but yes. So what we do here is we commit deletion. We commit a deletion. We commit deletion. Why did it quit? Yes, so we delete the fiber and the DOM parent with that. Okay. So we did pass the DOM parent, we have the fiber. Okay, and then function if fiber DOM exists, then just remove the child. Otherwise, you have to go to the child, to the child, to the child, to the child. So assume we have a h1 tag and its children is a it's a function component. It's a function component. So we cannot delete that. We can, if we are trying to delete that, we just have to kill all the child because that is already non-existent. We don't accept any infertile parent, so that is already not accepted. But we do have the real children, so we also have to delete them, and then we don't have to delete the parent because it's already deleted from the family tree. So yes, what I can do is go function. Yes, and then what we do is if fiber dot DOM exists, then what we do is remove from parent dot remove child fiber dot dom. Hopefully this is what we do. And else fiber is equal to dom fiber dot child. So this is what we do, right? Yeah, we remove the child fiber dot dom. Otherwise we call it with yeah, we are not running a loop here. Okay, cool. Nice, 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 nice. So we are doing this. Now we move on to the hooks. Nice. So we move on to the hooks. So now we will dynamically call render. So initial now what used to happen was, so I guess the code is ready for function components. Let us try that out first. So now what used to happen was okay, sorry. Yeah. So what used to happen was we used to trigger the render, and the render used to work whenever there was some update in the DOM. But how were we updating the DOM? We were not updating the DOM. We were just creating it once and we were just leaving it there. We never deleted anything. We never did anything. So if we want to do that, we need to have states. For that, we need to have hooks. So all the thing we did up until now was just creating the VDOM, not touching it at all. So we of course need to do that. So we will do that. First we will try to run this. Npm, hopefully npm start. Hopefully this should work. This worked. Okay, for that term, I can serve using Python. And I can go and do localhost 8000. And yes, it worked. It worked. It worked. It worked. What the fuck? So it worked. Yeah. Damn, it really worked. And how much file did it take? Just 2 files to create everything. Now I want to be ambitious. I'm just looking if I can create a demo website using that. Let's see. Let's not get ahead of ourselves. That's what she said. Okay. So 404. Okay. And then yeah, hooks. Last step, now that we have function components, let's also add state. Let's change our example to the classic counter component. Yeah, nice. Each time we click, it increments the state by 1. Note that we are using direct.useState to get and update the counter value. Here is where we call the counter function from the example. Okay, so we are creating a counter. Makes sense. So what I can do is just go here. Okay, so we just commented this part out. We create another function counter. And we just okay, so what is he doing? On click, set state. You can also create a button, right? We can create a button. Why do we want to make a counter out of it? Hmm. Yeah, we can create a button and we can create a button. And then we created a button and then we can uh, give a break. We can say one count is count and then slash h1. Okay, we can do this. Count is state and no, count is count. Count is not state. Fuck it. Then button we can say plus. And then we can pass on click. I guess the C should be capital yes. On click, we pass in an anonymous function which I never used to understand. So what we do is set state, which also gets a set state takes in a counter count count plus one. Okay. Since this is a callback, I don't need to specify the actual variable name here. Makes sense. And then what we can do is we first have to make the fonts count comma set count is equal to dot create state use state use state one. Why did I have to do zero? You're a programmer. You should start with zero, not one. And this is count and then yep, and then const element is equal to why. I'll just do this. And what if I compile it right now? This gets compiled. What I can do is suspend this cat build index.js. Okay, and then I can make it foreground Python. This is the queue, and then yeah, and now it is throwing error. Hello world is not defined at index. Okay. So I can just do this. Game starts. Yes. Okay. Object counter. Stack. sense. Makes sense. Makes sense. So what we can do right now is follow the tutorial. Follow the tutorial. Okay. So here is where we call the counter function from the example, and inside that function we call use state. The fuck? Here is where we call counter function from the example, and inside the function we call use state. Where is the counter for the function? Okay, so this is the counter function. Of course, it is a function element. You okay. Yes, of course, it is a call हो रहा था ये function. So, and inside that we call use state. Okay, so we are creating use state. The fuck, the fuck, the fuck, the fuck, the fuck is wrong, bhai? Like, use state should be in React, not in React DOM, as far as I know. So there is no segregation. So DOM actually takes a virtual DOM and then renders it on the real DOM, and React only creates the virtual DOM. So the point, okay. So we will move ahead with this tutorial, but I'll refactor the code later. So use state. Okay, we use the state, update host component and all that. Okay, 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 okay. We need to initialize some global variables before calling the function component, so we can use them inside of the use statement. Okay. So before we call the function component, we have to do something. Okay, so but isn't the work in progress fiber already defined? Or was it work in progress root? Okay. Okie 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 dokie. Yes, it was work in progress root, not fiber. So what we can do is so hook index is equal to null. Okay, and then whenever we are doing this, work in progress fiber is equal to fiber, of course, and hook index is set to 0. And then web dot fiber dot hook. Makes sense. So we first check if we had some old hooks attached to it. Is it console? Should be console is equal to sorry not dot hook and all. Okay, so if it checks if it has a older version of the hook or older hook there. Of course, it is index dependent. So if there is some change in sequence, won't be able to detect it. But it doesn't matter. This is a this is an optimization we could do, but it doesn't matter for now. It works. So const hook is equal to this state old hook, then old hook dot state. Otherwise, it is initial. Okay, so we instantiate a fucking hook. Const hook is equal to an object which contains a state. The state is old if old hook existed. If old hook existed, then it should be old should be so what it means to say is suspend and then we do node, we do const h is equal to 1 and 2 and 9. H is 9. Fuck, it takes on to the last value. Okay, and what if I do this? Makes sense. Const b is empty. Okay, and what if this had some key z as 10 and then I made it c damn. Mm, okay, so what we do is old hook dot state otherwise initial, but okay, makes sense. So hook is nothing but an object. Then we take the work in progress fiber. We then do dot hooks dot push and then we push the new hook. Why are we pushing it? That means it has context of all the previous states also. And then we hook index plus plus. Okay, but we haven't changed this. We do have to change this, right? हमने इसको we did it in we initialized it empty. Fifteen more this is getting wrong. What's wrong? Like not that everything is the problem. Okay, and we return the hook dot state. Okay, we return the hook dot state. We are returning any function yet, so we haven't created. Also returns a function To update the state, so we define a set state function that receives an action. So we push that action to a queue, we add to the hook, and then we do something similar to what we did in the render function. Set a new work in progress root as the next unit of work, so the work loop can start a new render phase. Okay, so we have an action queue. Okay, and when we use, so but I don't understand. अगर हम इधर जीरो कर रहे हैं, दो फंक्शन कॉल हो रहा है, अगर उधर जीरो कॉल हो रहा है, and then we go to use state, and then we have hook index plus plus, the fuck is going, it is going to be cleared every time we render the function component. Every time we are going to render the function component is going to get to zero, and we are removing the fucking hooks. How is it going to store the context? So of course we take the old hook, we take the hook from there, but the hook index is still zero, right? Still zero. Set the state, push it, and we increase the index. So good, good. We have work in progress root, we update it with dom as current root dot dom. So let us go to render. So we set it to content. We are not setting it to content. We're setting it to the current root. The current root is already rendered. And then we take the props. We take it to already render props. We take the alternate. That is also the current root. The fuck is wrong? Then what have we updated here? We need to update something, right? Like, right over here, we are updating it. Okay. You know what? I'll just copy this, and I don't mean to write this. You know what? But I should write it. Set state. So then we take the work in progress root, and then what does it have? It has a DOM. So we take the DOM and we make it to be current root dot DOM, if I'm not wrong. Yes. Then we have props. Then we have alternate as current root. Oh. So I made this change. Next unit of work is equal to root. So don't say we are again calling. So we have a render cycle and then we have a hook applying cycle. The fuck. But we haven't run the action yet. Of course we haven't run the action yet. we do it the next time we are rendering the component. We get all the actions from the old hook queue and then apply them one by one to the new hook state. So when we return the state, it's updated. So I understood this part. Why are we doing this? So we have a hook, it has a state and it has certain actions, certain callbacks which we can do. So it pushes it to the queue and then it updates the current route. It updates the current route so that we can again run a rendering cycle, which is work loop. If you are not, so work loop runs again because we updated the whip route, work in progress loop. So till then it was okay. Now we have some actions. So which is of course depends if we have old hooks. So if we have old hook, then we take old hook dot queue. Otherwise, we return it to be empty. So we don't have any queue. So for each action, so do actions dot for each. Let's just close it. Action, for each action we take the action, we fuck around with it. So what we do is hook dot state is equal to action of hook dot state. Okay, so the only unclear part which I have currently is that we have initialized it to 0 and we have update function component. It gets called and then we have to reconcile. Then it returns. No, it doesn't return. It returns the child. But we have set the hook index is equal to 0. And we have updated the hook index right over here. But where is it storing the index? And why is it doing that? Why, when I use state with an initial value, it checks if we have some old hooks. If it has some old hooks, if it has some old hooks, we take the state of it, or else we take the initial. Okay, and we have the empty queue. And then if it has some old queue pending, we apply it to the state and then we return a set state function which takes in an action, push it to the hook queue, which is empty, but now we have something inside it. And then it updates the working progress route so that we hit the render cycle again. And then we push it to the number of hooks we have. But every time a use state is called, it is creating a new hook. Makes sense. But every time set state is called, it specifically looks into that hook.queue and pushes it. Okay. Hmm. But it is a closure, right? We're returning a fucking code. It keeps alive all of the above stuff. So it has context of hook also inside it. Okay. But we haven't run the action yet. We do it the next time we are rendering the component. Okay, 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 okay. That's all. We built our own version of React. This is still very, very shady. Look at that. Where status boy, everything. One because there, then everything is there. Every fucking shit is there. Probably something is fuck. Whew. So this part is very difficult to understand. I will try personally myself to understand this part. It will take something. It is I am getting it what is happening right over here, but it's very difficult to understand it in simpler way. So now that they are saying this is done, we should be able to run our counter example. But we are not able to run it. What? 209. Then 209. Yes, this is a comma. This is a comma. Okay. Not a function, nor its return variable, not its a variable. Course, of course, of course. Because, because this is not in React namespace. This is React DOM, and then we do use state as use state. When I go to JSX, I do f dot, I do DOM. Hopefully this will work. The fuck is on the fuck, why is it 304? Okay, this isn't working. Hmm. Okay. Yep, we have this. Hmm. So what we can see here is we have the event time. What is your case? And we are removing event listener here. And is there a point? Yes, we are adding the event listener here. So again, console.log kingdom. Hmm. Okay. Next crop. Hmm. So so list event listeners connected to an element. Mm-hmm. Okay. I can do that. Okay. So what I can do is event listener. Right, there is a click. And there is this. Okay. So you have use capture, response. You set call and it is not executing it. Do I have something different? So you set state here which takes in an action, pushes it to the queue, then it executes the action. Action now hook dot state. Yes, it's just the same thing. Why isn't it working? Hmm. Okay, but this is what he did, right? Hmm. चलो देखते हैं, let us see. Okay, I don't know. So now we do hooks here. Okay, cool. So now we have say state and set state. We do one click. On click is equal to. Okay, so on click is equal to click is equal to, and then we have this count is equal to this. And then we do set state, set state, set state, set state. Okay, and what if I do this? What if I export this way? Okay, I am missing something. Whatever is that I'm missing, mostly I'm missing it in set state. So set state, okay, hooks dot push hook, You know what? Why do I want to keep this? Okay. Start create DOM. DOM it is update. It is update function component. This right over here. Not this. Okay. Okay. Value unavailable. Okay, cool. Of course, there is no alternate. Code hook is equal to null. Code hook is null. State is 0. Error of 0. So the actions is also empty. This does not execute the action. Okay. Has to be, so there is no action. Okay, but there's a push key. You should have pushed something, right? Maybe I don't know. Okay. So now here we go. So go ahead. Okay, we have fiber. We have hooks. Then we have, okay, we have hooks and we have hooks. Okay. Grab right over here. And then we just do execute this. Then we have initial is equal to 0. Nice. What will it be null? It will not define. Why? Mm-hmm. Why the fuck is it undefined? Why the fuck is it undefined? Hmm. It's because of this. It's because of this. It's because of this. If I go here, okay, go to definition of this. Yep, it's because of this. Okay, cool. So can I do this now? So we were not taking the hooks from the previous version. That's why it was undefined. It was an empty array. I had to do work in progress fiber dot alternate to take the previous hooks, which is already there. Okay, nice. So what I can do is dt, then do. So now this is this. Okay, so now I have to compile to run this. So every time I use state, it fucking re-renders the whole DOM. It re-renders everything in this. Wow. Re-renders everything. It doesn't re-render from what do you say? From the node where it has changed. It re-renders the fucking whole virtual DOM. Nice. 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 What I can do is okay, so just to be NBSP. Does this work? Okay, I have to compile this first. So NBSP in HTML. How do I write NBSP? NBSP. So they understand NBSP. I have done this. Oh, this is JSX. That's why it doesn't understand NBSP. It just maybe it just puts it under string. Yes. Nice. But then there are no conditionals in JSX, right? So if I want to compile conditionals, how would I do that? How will I do that? Of course, maybe I can do this. Const one comma set one is equal to react dom dot use state. Okay, I can do this, and then what I can do is style is equal to one. One is empty string. Okay, that everything set count executes every time on click. I just don't want to execute set count. I want to execute another condition with it. So what I can do is click callback is equal to of course set count click callback doesn't work like that. Okay, and then if I replace this with minus. Okay, so I can do this. Okay, okay, okay. Then so just a second. What did it do here? Oh yes, I cannot do that. Fuck it. Try to do this. Set one, and of course it takes a callback. It takes a big callback. One is equal to this. I do wrap it up on this, and then I have to call npm start. And what is the problem here? Okay, maybe. Okay, cannot null down the fuck. Where the fuck is it? Of course it does have a DOM. It does have a DOM, right? Hmm. Why is it? I think it's such a big problem. Okay. Now this does make sense. What we have set one, and then we taken an input. Just like this. Okay. Maybe we have to return this. If I do npm start, am I calling something? Const click callable. Okay, you know what? Maybe we cannot call it like this. Okay, what I have to do is okay. Now here's the thing. क्योंकि इसके पास काउंट द context ये zero है तो count is less than one ये तो पता क्या ये देखो नहीं क्यों हुआ काउंट तो जीरो था ना लेकिन less than one अरे okay so zero would be red of course it is not less than it is not less than it is equal to but context hasn't been updated now see, see, see. There are some weird side effects of this. And it's actually the same thing with React. You cannot technically do this. You will get the old context of count. So if you want the latest one, you have to pass it on to the separate render cycle. And I don't know how you can do that. So because it pushes onto a stack in the single cycle. So what maybe we can do is to okay, so there was something as use ref. Maybe you have to make this type of hook now. So if I create that hook, I'll be able to work. But now, first of all, for the part of refactoring. So what I have seen here is the virtual DOM is generally created by React. Whereas the real DOM, like, so if you can see create, oh sorry, not create, was create was name. Okay, so what was what bread? Root, commit root. This should be part of React DOM. Render should be a part of React DOM, if I'm not wrong. Commit work, what does commit work do? So it deletes it, creates it, commits it. Yes, commits it if it wants. Okay, so now, as far as I know, commit root, commit work, and render must be part of React DOM. Everything else, so everything else, but then we of course commit root over here and we perform the in perform, but performing this work. So does React actually work like that? Does it have some global variables which we, if we want to access, can we access them? But they won't be exported. I haven't exported the variables here, but those are global variables. So if I so let us take this. Okay, so let us take this and okay, and I'm doing this here. This thing. So it builds. And it doesn't throw any error. But it is a global thing. But then if I move it to React instead of React DOM, React DOM won't have access to that. That's a problem. What we can do. So we don't import it here, right? We can import it there. Maybe it was all meant to be a single file. But then if I want to separate the front end and the back end, so not in the great like in the same sense as front end and back end, but if I want to separate the virtual DOM and the DOM renderer, how can I do that? So React creates this DOM whenever it is free, but it also renders it whenever it is free. So if I do workbook, yeah. So maybe what we can do here is okay. So maybe what we can do here is maybe. So what we can do here is we can do something like this. Then rendering should be handled by React. So this work loop should do only this much, and then there should be a signal which is sent. Maybe that's why React DOM has a client thing. So it has a client thing. You create the client by attaching it to a container, and then you call render on that. And that client might be handling this part right over there. Interesting. So yeah, it's mostly time. So thanks for everyone watching. Mostly the series is over. So we were successful in creating this very basic example of set state. Maybe if we can add more functionalities, that would be better, like use ref and use effect and all that. But it definitely gave a better understanding of what is happening, how a render call triggered. So render call are triggered by first of all render, second some state changes. But then I do want to try something just a little. Yeah, let us see this. So so we can see we can do this, but as far as I know, there was an easy way. not the right website. Conditional rendering, yes. It's legacy. I know that it's legacy, legacy, legacy. Hmm. Okay. We can do that with any other way. So you have to do this kind of stuff. And this is easy if I'm not like mistaken. So what we can do is we can try this out with within our JSX file. What we can do is okay. So again we can create a okay. So what we can do is okay. So we do have this. We have this syntax. Nice. So can we do this? If no, we don't have to do if. We have to do so count greater than 10. Then so I guess this is what we are supposed to do. But we are wrapping them in brackets. So we do this. Okay, and then we can do this. Then we can wrap this up too. Let us current game start. It worked. Then we can go here. Run this. Count is too high. Damn, 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 damn. This works. This works. This works. This works. And what is it getting combined into? This is, and then we have build. Yes. So this gets compiled into, and every time since every time because of this because since count is a state, every time it renders called renders. So this is possible. Damn, we have like we have very like we have created a very good uh, part of React, to be honest. Use effects, and I know we are yet to do that, but still like this is great. And now I understand why we have hooks and all. It is to trigger the virtual DOM. Right. So besides helping you understand how React works, one of the goal of this post was is to make easier for you to deep dive into React code base. That's why we use the same variable and function name almost everywhere. For example, if you add a breakpoint in one of your function components in a real React app, The call stack should show you work loop, perform unit of work, update function component. Damn. We didn't include a lot of React features and optimizations. For example, there are few things that React does differently. In React, we are walking the whole tree during the render phase. React instead follows some hints and heuristics to skip entire subtrees where nothing changed. Damn, that's a very good optimization, and we can actually we can flag things accordingly. We are also walking the whole tree in the commit phase. React keeps a linked list with just the fibers that have effects and only visit those fibers. Damn. Every time we build a new work in progress tree, we create new objects for each fiber. React recycles the fibers from previous trees. When React receives a new update during the render phase, it throws away the work in progress tree and starts again from the root. React tags each update with an expiration timestamp and uses it to decide which update has a higher priority. It is complex. React is very complex. Very smart people are working on that. I don't know, but even reaching this much, even coding this small part of React actually teaches you a lot. There are also a few features that you can add easily. Use an object for the style prop. Okay. Flatten children array. Okay, flatten children array. Use effect hook and reconciliation by key. If you add any of these or other features to Redact, send a pull request to GitHub repo so others can see it. Thanks for reading. And if you want to comment, like, share, okay, cool. So I can take a look at this GitHub repo. Mhm. So what is this? Is this same thing? Okay, so this is the same thing. So okay. And you we do have pull requests. Mm, okay. Cool. Makes sense. Yeah. So thanks everyone for watching.